9.4, radius of convergence. Essential questions. What is convergence for a power series? What does the nth term test prove? What is a ratio test? Let's take a look at the symbol equal and look at its significance in different things that we've done in mathematics. Right here it signifies equality of numbers. Here it's signifying an equivalent expression. Here it's an equation, an open sentence that we can solve. And here this is an identity, which is very much the same as 2. And that's what we're going to be working with, equality in terms of an identity. So what values of x will this be an identity? Now remember, this comes from a geometric series, and we know that x has to be between -1 and 1. And if you take a look at the graph, all of these power polynomials here, as we create more and more terms on them, it looks like it's matching better and better to the graph between -1 and 1. So we know that x is converging between here. Now x absolutely converges at x equal to 0, which is the very center as we take a look at these power series and we add more and more terms. Now after x is greater than 1 or x is less than -1, we can see by the graph that the divergence is happening. Now this is not a proof, but visually we can see what's going on. This is the theorem that determines convergence, the 3 possibilities of convergence. One possibility is that from the point A you can go out R, and in the previous case we went out 1 from 0. 1 to the right, 1 to the left to get our interval of convergence right here, our interval of convergence. Now another possibility is that all x's work, and in that case the radius of convergence is infinity. In other words, from wherever you're at, you can go infinite to the right, infinite to the left. The last possibility is that the series only converges at the center and nothing else works after that. So the 2 terms we want to talk about is radius of convergence, how far out from the center, and the interval of convergence, where we're allowed to, in set notation, determine what the x values are. Nth term test. This is a test for divergence. Now, a series is not going to converge unless the terms are getting smaller and smaller. And what we say is that the difference of the partial sums have to be going to 0 in order for this to happen. So if the limit as n approaches infinity of the a sub n term fails to exist or is different from 0, in other words it's not getting smaller, then we say it diverges. Let's practice some problems. I'm going to take the limit as n approaches infinity of n over 2, and that answer is going to be infinity, which tells me the terms are getting larger and larger and larger, and there's not going to be any convergence happening when that does. So by the nth term test, since it's different from 0, we say it diverges. Now let's take the limit as n approaches infinity of this a sub n term. Now the answer is 0. Now that means the terms are getting smaller and smaller, but there's no guarantee that that's going to be convergence. All we can say is, all right, we have to investigate with another test. You can't say converging, because the nth term test is for diverging, not for converging. Let's take a look at the limit as n approaches infinity of this expression. And the answer is 1/2. Now 1/2 is different from 0, so by the nth term test we can say it diverges. And let's take a look at the limit as n approaches infinity of this expression. And the answer is 1. 1 is different from 0, so we say it diverges. Be very careful how you use the nth term test. All right, comparing non-negative series, the direct comparison test. We've had this before with improper integrals, and now we're going to have it with summations. Suppose that you know a convergent series, and if every term of the series that you're trying to find is less than the terms of the convergent series, then we say it converges. Now, if every term of something that you're looking at is greater than a series that diverges, then we say that the summation diverges. So let's take a look at a graph here, and maybe this will help you. So if an unknown series is underneath a convergent series, we can say it converges. So this unknown series will converge because it's underneath a converging series. Now, if a series lies above a diverging series, then we say it diverges. And that's what the direct comparison test is showing us. Okay, let's take a look at some examples. So here is a series that we don't know, and we're going to compare it to this. Now I know that's the hard part, is what do you compare to? And so we're comparing to something we know. And where have we seen this? Well, it's the Taylor series for e to the x squared. And we know that converges. And this is less than something that converges. So we can say that by the direct comparison test, that the unknown series also converges. As long as you can show that it lies underneath the convergent series, you're good. All right, let's also talk about the absolute convergence. We have talked about this one, but it's good to talk about it again. If the summation of the absolute values converges, then we say the series converges absolutely. So if all the non-negative terms in the series that you have there converges, then we can say any summation that has those terms, whether they're positive or negative, any kind of combination of it, we can say they also converge. Okay, so let's use that. Now, with sine, you know that sine can be positive or negative, and depending whether it's odd or even, we may have some positive or negative terms here. So we want to work with the absolute value here. And working with the absolute value here means that this numerator is going to be less than or equal to 1. The biggest it can be is 1, and there may be terms that are less than 1. Now, we are going to compare that with this, which we know is a convergent series that converges to e. Now, we can see that these terms are going to be less than this, so it's underneath a convergent series, and we can say this converges absolutely. And if this converges absolutely, then we can take the absolute value sign and say this converges absolutely. This converges as well.